Good morning, everyone. The first sign is difficulty focusing either up close, like reading a book, or at a distance, like seeing road signs clearly. What's happening here is often a mismatch between the mechanical lens of the eye and the flexibility of the ciliary muscles that support it. Microscope, one of the most effective tools we have to combat this, is visual anchoring, spending time each day shifting your gaze between near and far objects. This keeps the lens muscles supple and adaptive. Protocol tip: spend 5–10 minutes a day doing near, far drills. Hold your thumb in front of your face, focus on it, then shift focus to something far away like a tree or a building. Repeat this slowly for a few minutes. It's neuroplasticity for your eyes. Most people underestimate the profound impact that light has on the brain and body. Light isn't just something we see. It's a powerful biological signal that programs our entire physiology. The human eye contains specialized cells, intrinsically photosensitive retinal ganglion cells, that are not involved in vision directly. Instead, their primary function is to sense ambient light and relay that information to the suprachiasmatic nucleus, or SCN, in the brain. The SCN is essentially the brain's master clock. It governs your circadian rhythms, those roughly 24-hour cycles that regulate when you sleep, when you're alert, when your metabolism is optimal, and even when hormones like cortisol and melatonin are released. The most effective way to set this clock properly each day is exposure to natural light within the first 30 to 60 minutes of waking. This window is critical because, during this early part of the day, the retina is especially sensitive to the specific quality of sunlight that contains high amounts of blue light and UV radiation, wavelengths that stimulate those ganglion cells most efficiently. When these cells are activated by natural light, they send a robust signal to the SCN that says, "It's daytime, wake up, reset the circadian timer." Why is this important? Because so much of your mental and physical performance throughout the day depends on having this biological clock running on time. When the clock is properly anchored, you experience more stable energy, better focus, more resilience to stress, and more optimal hormone production. Importantly, the signal that sets the internal clock early in the day also determines when melatonin will be released later in the evening, roughly 14 to 16 hours after that initial light exposure. That means if you skip morning sunlight, or if you delay it by several hours, your whole sleep-wake cycle gets delayed. You might find yourself struggling to fall asleep at night, waking up groggy, or feeling mentally foggy through the day. But how does this relate to eye health specifically? When your circadian rhythm is dysregulated, it doesn't just impact sleep. It affects retinal health itself. The retina is a dynamic tissue that requires metabolic support, antioxidant activity, and cellular repair, all processes tightly regulated by circadian cues. Several studies have shown that misalignment in circadian rhythms can accelerate retinal degeneration, increase the risk for diseases like age-related macular degeneration, and even impact intraocular pressure, a key factor in glaucoma. Daily exposure to bright sunlight, especially in the morning, acts like a natural nutrient for the eyes. It strengthens the retinal ganglion cells, improves their communication with brain structures, and helps preserve their functional integrity over time. In short, it helps protect vision. Now, there's a right way and a wrong way to do this. You want to get outside without sunglasses if possible, but don't stare directly at the sun. Glass and windshields block some of the UV and blue light wavelengths that stimulate these ganglion cells, so being outside is critical, even if it's cloudy. On overcast days, the light intensity is still thousands of times greater than typical indoor lighting. Aim for 5–10 minutes of direct exposure on clear days, and 15–30 minutes on cloudy days. For those living in northern latitudes or dealing with short winter days, bright light therapy boxes can be used to mimic morning sunlight, but they must be of sufficient intensity, at least 10,000 lux, and ideally should be placed above eye level to mimic the natural angle of sunlight. It's also worth noting the timing. Exposure to light too late in the day, especially artificial light from screens, can send a mixed signal to the SCN. It confuses your brain into thinking it's still daytime and suppresses melatonin. This not only delays sleep, but also puts the retina in a state of oxidative stress, which, over time, can degrade visual function. There are downstream effects as well. Proper morning light exposure boosts dopamine production in the retina, a neurotransmitter not just associated with reward and mood, but also with protection against myopia or nearsightedness. Dopamine release in the retina seems to regulate eye growth, especially in children and adolescents. That's one reason why time spent outdoors is associated with lower risk of developing myopia. To summarize, getting natural sunlight in the morning is not just about feeling more awake. It's about setting the stage for a full day of optimized physiology, including visual performance and long-term eye health. It's one of the simplest, most cost-free interventions you can adopt, and it can literally change how your brain and eyes function, not just for the day, but across your lifespan. Start tomorrow, wake up, go outside, and face the morning light. It might just be the most powerful thing you do all day, for your vision, your sleep, and your brain. In today's digital age, most of us spend extended hours fixated on screens, whether it's a computer, tablet, or smartphone. What many don't realize is that prolonged screen exposure profoundly impacts the visual system, particularly the way our eyes and brain collaborate to maintain focus, clarity, and comfort. One of the most accessible yet effective tools to counteract this is the 20-20-20 rule, and the reasons behind its effectiveness are deeply rooted in the biology of the eye and the neuroscience of visual attention. Let's first understand what happens during prolonged screen use. When you're intensely focusing on a nearby screen, especially for long periods, your eyes remain in a constant state of accommodation. This means the lens inside your eye is continuously flexed to keep near objects in sharp focus. The ciliary muscles, which control the lens, are chronically contracted. Over time, this creates muscular fatigue, leading to a condition called asthenopia, or what we refer to as eye strain. You may experience blurry vision, a burning sensation in your eyes, difficulty refocusing, or even headaches. This isn't just a nuisance. It's a signal from your nervous system that your visual system is overworked. But there's more. During intense screen use, your blink rate also drops significantly, from a typical rate of 15 to 20 blinks per minute to as few as 4 or 5. This reduction in blinking compromises the tear film that coats your eyes, leading to dryness, irritation, and reduced visual clarity. It's not just the eyes that suffer. Your brain, particularly areas like the prefrontal cortex and parietal lobe involved in sustained attention, starts to fatigue due to a lack of visual variety and micro-rest. This is where the 20-20-20 rule comes in. Every 20 minutes, look at something 20 feet away for at least 20 seconds. It's simple but biologically powerful. Why 20 feet? Because it allows the ciliary muscles in your eye to relax completely. At that distance, your lens doesn't need to exert force to focus, which breaks the cycle of constant contraction and allows the muscles to reset. It's the visual equivalent of putting down a weight after holding it for too long. Just 20 seconds of this relaxation is enough to restore function, reduce fatigue, and prevent long-term dysfunction. From a neurological standpoint, looking at a distant object also creates a shift in attentional mode. When we're looking at a close object, we engage what's called the focal mode, of attention highly concentrated, narrow, and effortful. When we shift our gaze into the distance, we engage the panoramic mode of attention, which activates a different pattern of neural activity. This switch activates the default mode network in the brain, a system linked to creativity, self-reflection, and overall cognitive restoration. Essentially, it's not just your eyes that are getting a break, your brain is too. Importantly, these breaks also help offset a growing epidemic, computer vision syndrome (CVS). This is a modern disorder that includes symptoms like double vision, dry eyes, neck pain, and even postural misalignment, all stemming from prolonged screen exposure without adequate visual breaks. By implementing the 20-20-20 rule, you're giving your eyes the variation they evolved to require. For most of human history, our ancestors constantly shifted their gaze across different distances, from close-up tool use to scanning the horizon. Our biology hasn't adapted to the artificial demand of staring at one fixed focal plane for hours. Moreover, this practice isn't just about preventing discomfort, it may actually preserve long-term ocular health. Chronic overuse of the accommodation system has been correlated with the earlier onset of presbyopia, the age-related hardening of the lens, and may even contribute to progression of myopia or nearsightedness, especially in young people. To make this effective, you can stack this protocol with other habits. For instance, during your 20-second break, take a deep diaphragmatic breath. This helps increase vagal tone, reduce stress hormones, and calm your entire nervous system. Or blink intentionally during that time to hydrate your eyes and re-establish the tear film. Set a timer if needed. Use digital tools or browser extensions that remind you every 20 minutes to take a visual break. Better yet, create an environmental design that encourages natural eye movement, place a window in your line of sight, or decorate your workspace with objects at various distances. If you want to optimize your vision, focus, and brain performance across the day, don't just rely on willpower. Leverage biological rhythms, train your visual system the same way you'd train a muscle, with deliberate rest, variation, and care. The 20-20-20 rule isn't just a tip. It's a scientifically validated strategy to harmonize the eye-brain system. And if practiced consistently, it can transform how you feel at the end of a long day. Not just visually, but mentally as well. When we think about maintaining eye health, we often think in terms of avoiding damage, wearing sunglasses, limiting screen time, or using eye drops. But there's another side of eye care that's equally important and often overlooked, training the visual system just as you would train a muscle or a skill. One of the most powerful yet underutilized protocols for maintaining and even enhancing your vision is known as near-far focus training. To understand why this works, let's briefly look at how the eye focuses. Inside the eye is a structure called the lens, which bends light so it can hit the retina in just the right way to form a clear image. This lens is held in place and controlled by a group of tiny muscles called the ciliary muscles. When you look at something up close, these muscles contract to make the lens thicker. When you look at something far away, the muscles relax and the lens becomes thinner. This process is called accommodation. Here's the issue. In modern life, most people are locked into close-range vision for hours each day, staring at books, phones, or computer screens. As a result, the ciliary muscles are constantly in a contracted state. Over time, this leads to muscular fatigue, stiffness, and reduced lens flexibility, contributing to common vision problems like eye strain, blurry vision, and even the early onset of presbyopia, age-related inability to focus on close objects. Near-far drills directly counteract this by encouraging the lens and its muscles to move through their full range of motion. They are essentially resistance training for the eyes, enhancing both the mechanical flexibility of the lens and the neural circuits in the brain that control focus. Here's how to do it. Hold your thumb or any object about 10 inches in front of your face. Focus your vision sharply on the object. Then shift your focus to a distant object at least 20 feet away, like a tree, a wall, or a building. Hold that distant focus for 10-15 seconds, then return your gaze to the close object. Repeat this cycle for 2-3 minutes, once or twice per day. It seems simple, but this exercise activates several important systems. First, the ciliary muscles get practice contracting and relaxing. This promotes muscular health and lens elasticity, much like stretching keeps your joints healthy. Second, the visual cortex in the brain becomes more efficient at coordinating changes in focal depth, which is crucial for everything from reading to driving. In addition, the process of rapidly switching focus also stimulates the sympathetic and parasympathetic nervous systems. When you look at something far away, your system enters a more relaxed parasympathetic state. Close focus, on the other hand, is more sympathetic, slightly activating. Alternating between the two can improve autonomic flexibility, helping the body and brain regulate stress, attention, and energy more effectively. Another benefit relates to a concept called visual plasticity. Just as the brain can rewire itself in response to experience, the visual system can adapt and improve when given the right inputs. Practicing near-far transitions regularly helps maintain this plasticity, especially as we age. In fact, there's growing evidence that these kinds of vision exercises can slow or even partially reverse the progression of conditions like presbyopia and possibly reduce reliance on reading glasses. Importantly, near-far drills also enhance depth perception and spatial awareness. These skills are critical not only for athletes and performers, but also for reducing the risk of accidents, falls, and misjudgments in everyday life. Your ability to accurately gauge distances, movement, and object placement is directly tied to how well your visual system adapts to different focal planes. It's also worth noting that these drills are particularly useful for young people, especially those at risk for developing myopia, nearsightedness. Myopia is often associated with prolonged near work and lack of outdoor activity. By regularly engaging the far-focusing system, we send a biological signal that helps regulate eye growth and prevent the elongation of the eyeball that causes nearsightedness. You can even take this a step further by doing these drills outdoors. Natural light enhances the benefits by stimulating dopamine release in the retina, which contributes to healthy eye development and function. Ultimately, near-far focus drills represent a simple, low-cost, and highly effective strategy to train and preserve vision. Just like your muscles, your eyes need movement and variability. Static visual habits create stagnation, but deliberate shifts in focus stimulate growth, adaptability, and resilience. This isn't just about avoiding vision loss. It's about actively optimizing the system you use to interact with the world every second of every day. And it only takes a few minutes. 2 minutes in the morning, 2 in the evening. It's not about perfection. It's about repetition, intention, and using biology to your advantage. There's a hidden system in your body that's constantly working to keep your vision stable, even while your head moves, and it's known as the vestibulo-ocular reflex, or VOR. Most people don't realize how critical this reflex is until it starts to fail. When motion feels disorienting, when you get dizzy easily, or when your eyes struggle to lock onto moving objects. But by training the VOR regularly, you can not only maintain visual clarity during motion, but also enhance your balance, spatial orientation, and overall brain function. The vestibulo-ocular reflex is a beautifully coordinated system between your inner ear and your eyes. When you move your head in any direction, sensors in the semicircular canals of your inner ear detect that motion. Almost instantaneously, a signal is sent to your eye muscles via brainstem pathways, telling them to move in the opposite direction of your head movement. The result, your gaze remains stable on a fixed point even while your body is in motion. This system is vital for walking, running, reading while moving, playing sports, and essentially any task that combines motion with visual focus. Now, like any biological system, the VOR needs stimulation to stay healthy. In a modern environment, however, this system often goes understimulated. Most people spend their days in environments with minimal head motion, sitting at desks, looking at screens, walking slowly in straight lines. We rarely challenge our visual system to stabilize images during motion, and as a result, the reflex weakens. This can manifest in symptoms like blurred vision when moving, dizziness when turning your head quickly, or even difficulty focusing on text while walking. But here's the good news: the VOR is highly plastic. That means it can be trained and strengthened through targeted exercises. One of the most effective protocols is known as gaze stabilization training. Here's how it works. Choose a letter, object, or visual target directly in front of you, about eye level on a wall or surface. Fix your eyes on that target. Now move your head side to side, about 45 degrees in each direction, at a moderate pace while keeping your eyes locked on the target. Start with 30 seconds and build up to 1-2 minutes per session. As you improve, you can introduce up and down movements, diagonals, or even walking while maintaining fixation. This type of training stimulates the entire eye brain pathway responsible for keeping your vision stable. Initially, you may feel slightly dizzy or disoriented. That's normal. It's a sign your system is being challenged. With time, this fades, and you'll notice better control over your visual field during dynamic tasks. But the effects don't stop with visual stabilization. Activating the vestibulo-ocular system has a direct impact on postural balance. That's because the vestibular system also connects with areas of the brain responsible for body orientation, motor planning, and even emotional regulation. This is why dysfunction in this system is associated not only with balance issues, but also with increased anxiety, brain fog, and reduced cognitive endurance. From a neurological perspective, training the VOR also enhances communication between the cerebellum, which coordinates movement, the brainstem, which handles reflexes, and the frontal cortex, which governs higher order decisions and attention. When this loop is strong, people tend to report better reaction time, faster processing of motion, and less mental fatigue during long periods of focus. This is particularly relevant for athletes, performers, and anyone who engages in high-speed environments. Whether it's returning a tennis serve, driving on a highway, or navigating a crowded street, a well-tuned VOR enables faster responses and sharper situational awareness. It's also a powerful tool for aging populations. As we grow older, the vestibular system naturally begins to decline. This leads to balance issues, higher fall risk, and slower visual tracking. But by engaging in gaze stabilization exercises regularly, just 3 to 5 minutes a day, you can retain a high level of function well into advanced age. You can also increase complexity over time. For example, do the same head movements while standing on a soft surface, or while tracking a moving object instead of a fixed one. These variations create more robust adaptations in the visual, motor circuits and expand your functional capacity. To enhance this further, stack it with breath control or cold exposure to stimulate alertness and balance simultaneously. Doing so creates a multisensory integration effect, one that trains your brain to remain calm and focused even in chaotic or unpredictable environments. In essence, the vestibulo-ocular reflex is not just about keeping your vision stable, it's about keeping your brain stable. It underpins your ability to move through the world with clarity, precision, and confidence, and it's trainable. All it takes is a few minutes of intentional practice each day to unlock massive improvements in how you see, move, and respond to life in motion. One of the most important, yet often overlooked, factors impacting eye health and overall brain body function is your exposure to artificial light at night, particularly overhead lighting and blue light from screens. Light is not neutral. It's one of the most powerful environmental signals your biology responds to. It doesn't just help you see. It tells your brain what time of day it is, what hormones to release, when to feel alert, and when to prepare for sleep. Your retina is composed of specialized cells, including intrinsically photosensitive retinal ganglion cells, iPRGCs. These cells are not involved in forming visual images. Instead, they exist to detect ambient light, especially blue wavelengths, and send that information to the brain's superchi, asthmatic nucleus SCN, which is your master circadian clock. When these cells are stimulated, they essentially reset the timing of your biological day. Now here's the key point. These cells are most sensitive to blue light, and they remain active long after sunset if you're exposed to artificial lighting, especially from ceiling lights, LED bulbs, and digital screens. When you expose your eyes to bright artificial light late into the evening, those iPRGCs send a message to the SCN. It's still daytime. Stay awake, delay melatonin. As a result, your sleep onset is delayed, your sleep quality drops, and your retinal cells become more stressed, because the natural cycle of light and darkness that they're built to follow get disrupted. This disruption doesn't just affect sleep. Chronic suppression of melatonin and circadian misalignment have been linked to a range of issues, from insulin resistance, mood disturbances, and hormonal imbalance to long-term risks of age-related macular degeneration, AMD, and retinal thinning. So, what's the solution? It starts with reducing overhead and blue and rich light exposure in the hours leading up to bedtime, ideally 2-3 hours before sleep. That doesn't mean you have to live in darkness, but the quality, angle, and color of the light you expose your eyes to at night matters tremendously. One of the most effective strategies is to use dim, warm, toned lighting in the evening, like amber or red light bulbs, salt lamps, or warm Edison-style bulbs. These types of light have significantly less blue content and are far less stimulating to the IPRGC. Light from below eye level, like from table lamps or floor lights, also creates less activation of these photosensitive cells than light from above, which mimics the sun's midday position. Another useful intervention is the use of blue light blocking glasses. When worn in the evening, these glasses can reduce the amount of blue light that reaches your retina. While they're not a complete solution, they can reduce circadian disruption, especially in environments where dim lighting isn't an option. Also, consider the screens themselves: phones, computers, televisions. All of these emit blue light in abundance. Use night mode settings or screen filters to shift the color temperature toward warmer tones in the evening. Even better, try to reduce screen exposure entirely 30-60 minutes before bed. During this time, allow your visual system to experience darkness or candlelight, the natural cues your ancestors were exposed to before modern lighting existed. This isn't just about sleep hygiene, it's about restoring the natural light, dark rhythm that keeps your entire visual and hormonal system operating in sync. When this system functions properly, your retina gets the recovery time it needs during the night to repair oxidative stress, balance intraocular pressure, and recalibrate its responsiveness to the following day's light. Essentially, nighttime darkness is therapeutic for your visual system. There's also a downstream effect on dopamine production in the retina. Dopamine plays a role in regulating eye growth, visual processing, and even the development of myopia, nearsightedness. Dysregulated light input, especially exposure to bright light at the wrong times, can interfere with dopamine cycles, increasing the risk of refractive errors and visual fatigue. For children and adolescents whose eyes are still developing, this effect is even more pronounced. Consistent exposure to bright artificial light late into the evening has been associated with earlier onset of myopia and increased visual stress. To make this actionable, use warm, dim lighting after sunset. Keep lights at or below eye level in the evening. Avoid screens for 30-60 minutes before sleep. Use blue light blocking glasses if needed. Replace LED ceiling lights with amber or red alternatives. Where possible, these changes may seem small, but they have a compounding effect. Over weeks and months, limiting artificial light at night leads to deeper sleep, better retinal recovery, improved focus the next day, and long-term protection of your vision. We often chase supplements and advanced tools for eye health, but the most powerful tool is already built into your biology. Light is the most potent lever for regulating the rhythm of your visual system. Use it wisely, and your eyes and brain will thank you for decades to come. One of the most overlooked aspects of eye health is something so basic that we often don't even realize we're doing or not doing it. That is blinking. It seems automatic, subconscious, and unimportant. But in reality, blinking is a critical visual and neurological behavior, and disruptions to your blinking patterns can have significant consequences, not just for comfort, but for vision clarity, attention, regulation, and long-term eye health. Let's start with the biology of what blinking actually does. Each time you blink, you spread a thin layer of tear film over the surface of your eye. This isn't just to keep the eyes moist. It's to protect and nourish the cornea, the transparent front part of the eye that focuses most of the light entering the visual system. The tear film has 3 layers: lipid, aqueous, and mucin, and each one plays a vital role in keeping the eye surface smooth, clear, and resistant to infection. When we blink at a healthy rate, roughly 15 to 20 times per minute, this tear film remains stable. It maintains optical clarity, reduces inflammation, and creates a physical and biochemical barrier that protects against environmental irritants like dust, wind, and pathogens. But when we reduce our blink rate, especially during intense visual tasks like reading, gaming, or working on a screen, the tear film breaks down. This leads to what's called evaporative dry eye, a condition where the surface of the eye becomes exposed and starts to dry out. The symptoms can be subtle, slight burning, a feeling of grittiness, visual fatigue, but over time they can escalate into chronic irritation, inflammation, and even abrasions on the corneal surface. This not only reduces visual clarity, but can also alter the neural processing of visual information. Blurred vision, light sensitivity, and slower visual reflexes are all possible outcomes of chronic dry eye syndrome. Now here's where things get even more interesting. Blinking is not just mechanical. It's tied into your brain's attentional system. During periods of high cognitive load or deep concentration, like when you're writing, editing, scrolling, or analyzing something, your prefrontal cortex suppresses the motor circuits responsible for blinking. This is an adaptive mechanism. The brain wants to minimize interruptions during peak focus. But the unintended cost is that the visual system doesn't get the refresh it needs. In some people, the blink rate drops as low as 3 to 5 blinks per minute during screen time. That's a 70% reduction in tear film renewal, and it places the cornea in a near-constant state of exposure to oxidative stress. Over time, this can contribute to ocular surface disease, increased sensitivity to light, and a higher risk for infections due to compromised epithelial defense. Fortunately, blinking is trainable. The first step is awareness. Simply knowing that your blink rate drops during screen use can prompt behavioral changes. One useful technique is the conscious blink reset protocol. Every 10-15 minutes, pause your activity and perform 5 to 10 full, intentional blinks. This resets the tear film, relaxes the extraocular muscles, and provides a brief neurological reset, much like a breath does for the lungs. To optimize this even further, combine your blink reset with visual breaks. For example, pair it with the 20-20-20 rule every 20 minutes. Look at something 20 feet away for 20 seconds to give both your eyes and brain a dual recovery. You can also train complete blinking. Many people who experience dry eyes don't actually close their eyelids fully during a blink. Incomplete blinking leads to dry patches, especially near the lower part of the cornea. Full, slow blinking ensures that the entire surface of the eye receives the tear film and helps stimulate meibomian glands, which release oil to stabilize tears and reduce evaporation. Hydration is another important factor. Systemic dehydration affects tear production, so drinking adequate water throughout the day supports the aqueous layer of the tear film. Omega-3 fatty acids have also been shown to improve the quality of the meibomian gland secretions, further protecting against dry eye symptoms. If you wear contact lenses or live in dry environments, you may need to support blinking with lubricating eye drops, but avoid those with preservatives for long-term use, as they can cause irritation over time. Look for artificial tears that mimic the natural tear composition and use them preventatively, not just when symptoms arise. And always ahead of the curve acts as there's neuroscience reset R in doing the mechanism. Studies using EEG and fMRI have shown that blinking temporarily shifts the brain into a more introspective state, reducing activity in the visual cortex and increasing activity in the default mode network, a system linked to creativity, self-awareness, and recovery. So blinking isn't just about eye protection, it's about brain optimization too. In short, blinking is a micro behavior with macro impact. When done correctly and consistently, it safeguards your vision, enhances mental clarity, and promotes long-term ocular health. In the digital age, where screen time is nearly unavoidable, learning to blink with intention may be one of the simplest and most effective habits you can cultivate for your eyes, your brain, and your entire nervous system.